And we continue with Mainframe Modernization and SOA 2 right now with our discussion of tools, technologies, and best practices to increase the business value of legacy assets through cost-effective modernization and SOA. This is Vance McCarthy, Program Director for Mainframe Modernization and SOA, and I'm pleased to be joined right now by Jim Crew, VP of SOA at SOA Software. Jim, welcome back.
Thank you, Vance. Appreciate it.
Jim Crew knows well the worlds of mainframe and SOA and how they can best be brought together for business and IT. In fact, he's the inventor of SOLA for mainframe web service offerings at SOA Software. Jim developed SOLA while he was the Director of Infrastructure at Merrill Lynch. And in its earliest deployment, SOA logged $42 million in savings and optimizations at that firm. Jim also brings a valuable customer perspective to our event today with 28 years as a financial services IT professional. In his talk today, SOLA Mainframe SOA, Jim discusses more responsive applications, faster end-to-end integration, saving valuable mainframe MIPS, and simply making the business better able to quickly respond to new business opportunities. And now, Jim, tell us about SOLA Mainframe SOA.
Well, thank you, Vance. I really appreciate it. Thank you very much for that kind introduction. Hello, everybody. My name is Jim Crew. So I'm going to be talking to you today about SOLA, which is SOA Software's offering. It's a fully integrated offering for mainframe SOA, making the mainframe a true participant in an enterprise-wide SOA. So what are we doing here? What are we thinking about when we're trying to connect the mainframe into the SOA world? The SOA world is XML and Java and WSDL and all these strange technologies. From a mainframe programmer's perspective, that doesn't seem to make sense. Well, what we're talking about here is simply taking our mainframe assets and making them into reusable web services. What that essentially is giving you a consistent and coherent strategy. That's a way of consistently exposing applications across your enterprise so that a Unix application, a Windows application, can look the same as would a mainframe COBOL application or a 3270 transaction would look. So they all have the same consistent way of being executed. What does that give me? Well, it gives me the ability to save a lot of money because I don't have to have multiple different integration strategies if I'm executing a service on Windows and executing a service running written in COBOL, for example, on the mainframe. And data is fresh. Now, what does that mean? One of the things that we see, and I used to, as Vance was saying, I used to be in a very big company. One of the things that we used to do was copy data all over the place because that was how you did things. And so we'd copy our mainframe customer data down and we put it on distributed databases. And we did that because we wanted to be able to read it from distributed applications. What we were finding, of course, was that our data wasn't fresh anymore. So if it had been updated on the mainframe, it was no longer fresh on the distributed platform. By integrating an application that surrounds that data and integrating that on the mainframe platform, we're looking at fresh data. And, of course, it eliminates reprogramming. One of the things we had to do if you were copying the data, we also had to replicate a lot of the programming, which was the business sense that connected those data pieces together. So one of the things we also think is important is running your SOAP stack on the mainframe. A SOAP stack is essentially the complete processing that you have to do to take an XML message, a SOAP request, and transform it by means of parsing and security and data transformations into a message that can be understood by a legacy program. If you run that on the mainframe, we see that gives you much, much higher performance and reliability, and it eliminates the data replication issues that you have going forward. So also we think it's really important to make the mainframe an essential component of your enterprise SOA. And I mentioned this already, that it's very critical, we believe, that the mainframe should operate exactly the same way as all of your other systems. So what do we mean when we talk about SOA? Well, what we're talking about here is program. Let's say, for example, you have a COBOL program. That COBOL program exposes a name search function. What we're going to do is that program is, think of it as a service. That name search is a service. It's going to expose itself by means of a contract. A contract is saying, this is how you can invoke my program. So it implements a contract. It publishes a contract. And that contract is WSDL, Web Services Description Language. Your program publishes that. A consumer, the person who wants to use it, maybe running on Unix, for example, would use that WSDL and understand that WSDL, and that tells them how we can actually execute your program. Your program will send a SOAP message, and your consumer will receive that SOAP message. It will all be done by means of an endpoint. the consumer will bind to the endpoint. Your program will expose that endpoint. This is basically the basics of SOAP. But it all fits together by means of policy. Policy is the most important part because it's policy that tells you how to execute that service. You've got to provide a user ID and password, for example. You've got to authenticate yourself. You need to encrypt. You need to sign your messages. So policy is the piece which pulls the whole thing together, which says that this person is able to execute this service and using these sets of credentials and execute in this type of way. So policy is very, very critical and most important part. So when we're looking at SOA, what are the goals here? What are we trying to do? Well, firstly, we're attempting to modernize our infrastructure, and we're trying to reduce cost. We're reducing cost through reuse because we're using standards. Because we're using standards, it's much easier to connect things together because everybody follows the same standard. We achieve that through means of governance. Governance is a word you're going to hear me say a lot. Governance is basically the laws, the rules which surround what it is you're doing and how you do it. And there's governance around security, there's governance around development, there's governance around standards, there's governance around monitoring and logging and changing. So everything is governed. And you need to really be thinking very clearly about governance. And then finally, you need a registry and repository because you've got to be able to document services. If you're going to achieve reuse, you've got to document it somewhere so that you can be found somewhere else. What does it give you? It gives much higher agility because now if everything in my enterprise is exposed to the service, then it becomes much easier for me to connect them together. I no longer have to write specialized code or do specialized things or copy data in order that I can make use of the assets I already have. And it gives me the ability to do service abstraction, and I can do it by means of defining policies. I have policies. I can define policies across my enterprise which describe how things are put together. And I can orchestrate things together. I can orchestrate, for example, a service which is running on Unix with a service which is running on the mainframe, and it can be all part of a single orchestration, make it part of a single service. What this does is it's a paradigm changer. What we're doing with SOA is we're trying to align business and IT in such a way that we're now driving this from the business sense and not necessarily from the IT sense. So what do we believe is the winning strategy for mainframe SOA? Primarily, I mentioned this before, running the SOAP stack on the mainframe, that gives you much, much higher performance, much, much higher reliability, and much, much higher scalability. And these are really critical things. On the mainframe space, that's the game. It's keeping it up and running at low cost. If you run your SOAP stack on the mainframe, you're going to be able to take advantage of the power of the mainframe. Those are things like its reliability, its performance, its scalability, its manageability, and its cost effectiveness. And we have our SOA right next to our mainframe assets, and that is eliminating, in many respects, the last mile issues that you would have if you were doing things on a middle-tier platform and then calling the mainframe. If you're doing everything actually right on the mainframe, then you're eliminating the last mile issues around security, for example. If we enforce governance on the mainframe, then the mainframe is actually becoming an integrated part of an overall governance strategy, a unified governance strategy. So it's really important that that your governance tools, your governance strategy, your policy all runs with the mainframe. What this is doing is lowering my risk, it's increasing my agility, and it's consistently enforcing governance across my enterprises, giving me the ability to look at my whole enterprise holistically rather than as a set of disparate components. So what are the most important things I need to do? Well, obviously functionality. Does it do what I need? Does it do a 3270 transaction? Does it do a Kix program? Does it do containers? Does it do an IMS segment transaction? Those sort of things. Can it perform well? Does it do it quickly? Does it do it in such a way that I meet my goals? Can I govern it? Again, talking about governance. Can I govern it? Can I manage it? Can I control it? Can I change it? Can I secure it? Risk. How can I maximize my usability and minimize the disruption? Now, that's really, really critical. On the mainframe, we tend to be running a business, and people are really intolerant of things that disrupt that business. And finally, cost. Cost is really a major issue here. How can I do all of this at the lowest possible cost? So moving on. So we've got a mainframe running millions and millions of transactions a day. They're running COBOL, they're running PL1, they're running Natural, they're 3270 transactions, they're running in Kix, they're running in Batch, they're running in IMS. Nothing really fits together. How can we take that and move it into a fully integrated set so that everything works together, so we can expose it as services, we can manage it as one, we can govern it as one, we can monitor it as one, we can secure it as one, and make it reusable so it becomes easier for the outside world to use it. One Well, that obviously is the goal. This is our view of the whole SOA ecosystem. This is actually the SOA Software Unified Governance Automation Products slide, and this is what we believe the different steps are in an overall SOA, from identifying candidates for services, doing analysis, doing design work, moving into development, into testing, staging them for production, releasing them in production, operations, and then finally deprecation. That's the life cycle across all the different assets you've got in your service architecture, things like the services themselves, the policies, the profiles, the test cases, and so on and so forth. And what we have here is a fully integrated product set which allows us to manage that entire investment, that entire ecosystem, so that we can identify services, we can manage them via policy, we can develop them, we can operate them, and secure them all across one unified set of products. That's the vision that we have, and that's the goal, and that's actually the reality of our product set. So what does it mean, unified SOA governance, automation, and the mainframe? Well, from a planning perspective, we have products like the portfolio manager and the policy manager for identifying and planning. We have development products like the repository manager and the policy manager for actually doing things like development and securing and managing and setting standards for development. From an operations perspective, we have our service manager product, our policy manager product for making sure that our services are run the right way. And then from the mainframe, we have the SOLA products. So there are two of them, the SOLA for CICS and SOLA for IMS, which integrate into the other products so that they can provide a development and a runtime platform that is managed and integrated across the whole ecosystem. So looking at the mainframe as a governance service platform, what we're doing, obviously, as I mentioned this before, we're leveraging that massive investment by exposing those mainframe applications to services. And it becomes a part of our core application development process. It becomes a first-class citizen in the overall SOA ecosystem. And what we're doing by means of policy and planning and everything else, we're making sure the right people are responsible for the right functions. We're making sure those functions are being built correctly, they're being built according to standards, and they're being secured correctly. And without this effective SOA program, looking at more than just web service, but looking at SOA across the enterprise, what you can see is that companies are going to waste a huge amount of money because they're not effectively making use of these services they've already built. So the mainframe is a governance service platform. What we're doing here is we're allowing our mainframe applications to consume web services as well as being providers of web services and providing policy, security, management, reliability, and configurations. Moving forward, what do we need to think about in terms of moving to SOA when SOA incorporates the mainframe? There are three things we think about. Firstly, the essential components. That's what do we need to build an SOA? So what parts do we need to be doing? Secondly, practically, what do we need to run the SOA? And then thirdly, integration. How are we going to manage the mainframe as part of our enterprise SOA? So firstly, let's look at mainframe SOA or just web services. I've mentioned this before in passing, but let me talk about it in a little more detail. SOA, service-oriented architecture, is this architectural methodology for loose coupling and management of services. What that is, as I said before, this is this overall approach via policy, via security, via management, via monitoring of the whole SOA ecosystem. And it's really all around governance. SOLA is the product that does that on the mainframe space. You can go out and look at the marketplace. You're going to see there are lots of products out there that do SOAP and XML web services, but they're not looking at the overall problem space. They're just looking at the XML SOAP problem, which is only a small part of the overall problem. So let's talk about what it is, what that means. So you're looking at these 9 billiard balls here. The billiard ball in the middle, SOAP and XML capability. That obviously is the core piece here. In order to be able to say that you are a web services product, you have to be able to do SOAP and XML. But there's a lot more to it than that. You need also to be thinking about security. How am I going to secure these services? Am I going to use RACF? Am I going to use ACF2? Am I going to use LDAP? What methodology am I using for authorization and authentication? Am I using SAML, for example? Am I using XACML? How I'm managing my overall system, I need to think about policy, because it's policy, WS policy, that you use to actually specify how your SOA should be built, should be secured. This is policy and governance are really the same thing. Policy is an implementation of governance. How am I building things? How am I securing them? How am I managing them? So you need to have a policy implementation. You need to be thinking about a registry because everything needs to be documented. So you have to be thinking about everything automatically needs to be put into a registry. You need to be thinking about supporting architectural standards. So, I mean, it's pretty straightforward. It's very easy. I'm sure we can all think about how you could do this. So taking a copybook, for example, and publishing a WSDL for that. Very simple to do, easy to do, solves 1/100th of the problem. Because what we've built there is a web service that looks like your COBOL copybook. I'm not sure that that's particularly useful because what you're probably going to find is that your SOA architect wants to design your SOA ecosystem, but your SOA services, he's probably going to give you WSDL to begin with. So what you need to be able to do is say, well, I want to take my existing program, and I want to take this WSDL I've just been given, I want to figure out a way of marrying them together. So that's an architectural construct. We refer to that as WSDL first, of marrying, if you like, a mainframe program to an existing WSDL. Then there are things like standards. How am I going to make sure that I've got the right naming standards? Just for a very simple example. I've got monitoring, logging, and auditing. One huge part of governance is making sure that things work properly, that I'm meeting my SLAs. You can't meet your SLAs if you can't measure what's being done. So measurement is huge. So what you need is to be able to monitor, log, and audit all your transactions, and that feeds you data into then determine whether you're meeting the SLAs for your services. You need to be thinking about change and release management. It's really easy to think about this in terms of creating a service, but now I've created a WSDL, which I'm going to give to a distributed guy, and I've created some mainframe artifact which describes what I'm doing here. I need to be able to migrate those into production, back them out of production. I need to have multiple versions of them. I want to have a production version, a test version, a QA version, whatever else I've got to have. I suddenly have created myself a change problem, a change and release problem that I really need to think about. And that's a very, very big issue. I need to think about workflow. How am I going to do? I've got multiple little things that I'm doing. Maybe I've got a stock price lookup on the mainframe. Maybe I've got a customer name lookup on the mainframe. If I want to pull those together into an orchestration, I need to be thinking about how I can orchestrate so multiple different things can be executed. And maybe I've got a service that's running on Unix that I want to orchestrate with a 3270 transaction. So those workflow is really critical. And then finally, development tools. You want to be thinking about how you're going to be doing. We're actually going to be taking our existing programs and publishing services. How is that going to be done? What tools am I going to need? Do I need to have multiple tools? What workstations do I need to run those tools on? Can I run that at home at the same time as doing the work? So those are the essential components. These are things you need to be thinking about up front. So SOLA, how does SOLA do with this stuff? Well, SOLA offers a complete solution for KICS and IMS. It has this highly efficient SOAP process I mentioned before with a graphical development studio, which is this one single Web 2.0 development environment for actually developing services. Comes with an integrated registry repository, and you can integrate it with a UDDI v3 registry, for example. It supports WS security, WCF policy natively on the mainframe. That's a huge, huge thing. It has a management console with graphical graphing tools for viewing the executions of your transactions as they're going through. It has a BIPL orchestration capability, which is a huge feature. It's the only BIPL engine running natively on the mainframe. Supports your architectural standards like WSDL first, I talked about this before, the bottom-up paradigm, the meet-in-the-middle paradigm, which is where you've got an existing program and an existing WSDL, you can marry them together. Has a global dictionary for normalization of services. I'm going to do a quick demo of this later on in the presentation, you'll see. It integrates with existing change management systems. So if you have, for example, ZMF ChangeMan or Endeavor or SCLM, you can integrate SOLA into that service, into that system, which is a really huge thing. And it has a versioning capability, and, of course, it supports your software development lifecycle. And it's part of this integrated product suite. So it means it manages the services in the same way that all the other products manage the services. So we're now going to look at the practical components of enterprise SOA. So what do we have here? There are 5 things to think about. Human assets. The human assets, that's who's actually doing the work. We believe that if you've got a COBOL program, for example, and you're going to take that COBOL program and publish it as a service, the best person to do that work is the COBOL programmer. If you can provide that COBOL programmer with tools to make it easy for them to do that, without them having to understand Java or .NET or C#, but without having to understand WSDL or XML, But if you give them tools that make them highly productive and produce those things for them automatically, then you really use your human assets in the right way. You need to think about scalability and adaptability. Now, scalability and adaptability is how can you take a transaction and run it at low volume or at extremely high volume. And I may have mentioned this already. We run the world's largest mainframe SOA implementations with SOLA. And we do it because we do it on the mainframe. It gives us the ability to actually exploit the scalability and adaptability of the mainframe platform because it exploits the Kixplex and the Sysplex architecture. It gives you that scalability and adaptability capability. From an infrastructure perspective, what are you going to have to put in your data center in order to run this stuff? And which pieces of that are going to work? And when things fail, how can you determine which pieces fail? From an infrastructure perspective, SOLA requires a SOAP stack running on the mainframe, and there's no Java. It runs entirely on the general purpose processor, and mostly in assembler. It runs at very, very, very high performance, and much, much less CPU than you would expect. Much less CPU, for example, than a Java implementation you're going to see. From a development perspective, what do I actually need to deploy? So what SOLA has is a single J2E application server, and the SOLA Studio is accessible via a browser. It's a Web 2.0 browser-based application. Very nice, graphical drag and drop. It looks a little like Microsoft Visual Studio. Works like Microsoft Visual Studio, but it's entirely accessible through a browser. So there's no software distribution issues. It's got a single centralized implementation, very straightforward to use. SOA Software SOLA. Yes, it does. It's focused on the large enterprise. It addresses the problems of the large enterprise. Really, it's looking at operations and it's looking at development. How can you run this? How you can develop this? There's no middle-tier service required. It gives you end-to-end monitoring. Because it runs the SOAP stack on the mainframe, it gives you that really high performance and very low CPU cost. It's a standards-based implementation. The security is based on the WS security. So we have a complete WS security implementation running natively in the mainframe and a WS policy engine running natively on the mainframe. It's the only product out there that does this. That gives you, it eliminates your security issues because there's no last-mile security issues here. It's a fully standards-based implementation, written in mainframe languages, I might add, running natively on the mainframe. It has a centralized registry repository, so all services are automatically documented. When you create a service with SOLA, it's automatically documented in the registry. And it's the owner of the service, that's the COBOL programmer, for example, who's publishing that service. And they don't need to have, there's no coding or scripting to be done. It's very straightforward. It's very easy to use. So that means they don't have to know Java, XML, or anything else to actually take a program and publish as a service. Operates as a client as well as a server. It's integrated monitoring, logging, testing tools, which make it very easy for you to publish a service, test it, make sure it works, see what your performance size, and so on and so forth. It's got SLA management capabilities. It's actually monitoring the SLAs. You can establish an SLA for service. It's going to monitor that as each one gets run, and will notify you if it's not meeting your SLAs. You integrate it with your change management system and integrate it with the overall SOA software, service manager, change manager, policy manager, repository manager products, for example. So just looking at the product architecture, I mean, this is a very simplistic picture, of course, but the SOLA developer J2E application server I mentioned before, and then it gives you the ability to take Kix applications, publish as services, IMS applications, publish as services. So from a developer perspective, you have the developer. From a runtime perspective, the developer is not involved. It's just the actual applications that are being executed, and there's very deep integration with RACF or ACF2 if you're using mainframe SAF type auth IDs. It integrates with a SAML. It uses ICSF, encryption, decryption, signature validation. But let me just give you a quick demo. So let's say, for example, I'm going to take a program. It's a name search program I'm going to publish as a service. So I go to the SOLA directory. I choose my project. In this case, it's a SOLA demo project. I click import program. When I do that, up comes an import screen. I type in the name of the program, I give the name of the structure, DFH.com area, and I click the import button. Now, what we're doing in this case is we're importing a compile listing of the program, not a copybook. We're putting the entire program. What SOLA is going to do is going to read the source code of the program. It's going to read the procedural code, and it's going to determine what it refers to as a program signature. What that is, it tells it how each of the fields inside DFH.com area are being used, which ones are input, which ones are output, and so on and so forth. That's a huge works time saver later on. So once it's being imported, we just click Analyze. So we're going to create a method. A method is a web service operation. So we created already a web service. Well, now we're going to create an operation. So we go into the analysis page and we just say, this is the name of the web service. It's going to be called name search. And we click on Analyze button. When we do that, what we get is 3 panes. You've got the DFH com area pane on the left. That's a picture of your com area and with all the fields. So that's just the tree of your com area. And on the right, there are 2 panes. There's the schema inputs pane and the schema outputs pane. SOLA has figured out which of the fields in your com area are input and which of the fields in your com area output, as I said before, because it read the program, so it knows that. And so it's put them in the appropriate schemas. We can actually now click the Finalize button, and we have a service. It's a real service that would actually work. But unfortunately, it's going to be publishing things like WS Boss ID, WS Search Value, WS Access Method, which are not things that we want to use. We'd like to normalize these names so they're actually usable. So what we're going to do, we're going to click on the Apply Dictionary button. And when we click on the Apply Dictionary button, SOLA has this heuristic tokenizing dictionary. And what it's going to do is actually going to use this heuristic algorithm to convert your fields like boss IDs, WS search type, into the names that you want to publish them under. In this case, it becomes search type. It becomes return message, for example. So one click of a button, I'm done. The service I've created is automatically governed by a policy, so now it cannot be executed unless I conform to that policy. And this is just essentially another picture of the Web tool interface of SOLA, showing you doing a BIPL orchestration. And finally, here's a picture of the SOLA Resource Manager. This is our management tool. We have a management console and dashboard. The resources, the certificates, the policies, the access rights, the alerts, which are the SLAs, manageable through this dashboard. So in summary, what I've showed you is SOLA runs the world's biggest mainframe SOA implementations. It's optimized really for efficiency and low CPU consumption. And it's the only product running WS Security and WS Policy on the mainframe. That's a huge, huge thing. And as I said before, it runs the entire SOAP stack on the mainframe, and it's integrated with SOA Software, Service Manager, Policy Manager, Repository Manager, making it part of the unified governance automation product suite. For more information, please visit our website, www.soa.com, and we have a page /mainframe, which you can go and download any more information. So at that, I want to thank you very much and pass it back to Vance.
Jim, thanks very much for that look at the business benefits, the IT benefits, and a little tour of how the architecture actually works. Very, very well done in under a half hour. I really appreciate your tour. With your permission, I'd like to take you right to questions, because a few of them did come in.
All right, sure. Thank you, Vance.
Let me start with a question we're asking all of our speakers this morning. In this environment of tough budgets, where do you find the most typical mainframe SOA project to work on or to spec out today?
Well, what we've seen over the past few years is a lot of people have been looking at moving off of the mainframe and then realized that that's actually much, much harder to do than they originally conceived. So now what they're looking at is making use of what they already have on the mainframe. So you're going to say things like your customer name and address, for example, is a perfect application that you're now going to try to find a way of integrating across all of your disparate applications, so that rather than copying your name and address information from your mainframe down onto distributed platforms, we're now going to use that information at source. And that's an area that we're seeing a lot of, trying to find ways of reusing what we already own.
Excellent, excellent. Let me now turn to some specific customer questions about your technology. Let's start with this one. I like SOLA's no coding or scripting approach, but I have a question about what happens to my assets. Are my assets wrapped, WSDL'd, or transformed?
I would say they were wrapped. What we do is we actually provide a proxy for that. We create a series of runtime metadata, and that we have our runtime uses that metadata to transform incoming SOAP requests into your legacy formats, and then take your legacy formats and transform them back into SOAP responses. So I guess you could say we're wrapping them. There's no modification to your program whatsoever. Your transaction, your program carries on working exactly the same as it always did. It's just that there's a different way of executing it there as well.
Another topic here that caught attendee interest. Your automated governance feature for Mainframe to SOA sounds very intriguing. Does that mean you help me retain my SLAs and QoS across SOA to Mainframe transactions?
Oh, most definitely, yes. That's one of the goals here, is measuring and effectively retaining that quality of service. But, of course, you can't know that you're maintaining your quality service unless you're doing the measurement. So that's an awful lot of that is in the monitoring and the auditing stuff that we do. But, yeah, that's the goal, and that's what we're doing here is looking across an enterprise and then collecting all that metric data and putting it into one single place so that you can look at end-to-end across web services invocation that may have involved many different platforms with many different web services, and bringing that data all together and being able to present it in one single unified format. You can create a web services solution which does everything that we've talked about today, where I've got programs receiving SOAP messages and returning SOAP responses. But because it's not being governed, I have no idea what's going on. I can't tell whether it was working, whether it's not working, whether it's being secured. I could be being hacked and not know about it. So the whole unified governance story is absolutely critical to success, because without it, you don't know whether or not you're succeeding, and you don't know where you're failing.
Excellent point, excellent point. And our final question here, which is a kind of a theme we've had throughout the day, does SOLA add to or reduce my mainframe MIPS or CPU load?
Well, it's actually doing slightly more work on the mainframe. It's taking, it's doing that mediation we mentioned before, SOAP request into legacy format. So it has to increase your CPU consumption, but it is as minimal as we can possibly make it.
And are you able to leverage any of the specialty engines the mainframe has at this point?
Well, actually, Vance, we did a lot of testing on that, and we found that we come out much cheaper than using a specialty engine. So if the specialty engine is running Java, the application assist processor, what we find is that we actually run in less general-purpose CPU than if we were using the ZIP or the ZAP processor, because there's something like a 10% overhead in going to that processor. We come in under that 10%.
Excellent. Jim Carew, Vice President of SOLA at SOA Software, thank you very much for such a terrific view of SOLA's architecture and for taking so many questions today.
Well, thank you very much, Vance. I really appreciate the time.